We are solving two problems in current electricity. The first one is basing on meter bridge given in NEET 2020. Let us see what this question says. A resistance wire connected in the left gap of a meter bridge balances a 10 ohms resistor connected in the right gap. You know, in meter bridge, when the bridge is balanced, P by Q equal to L by 100 minus L is the formula, right. It is actually resistance directly proportional to length is the concept. I am not going in detail that how does a meter bridge works, what it is. I have done a very detailed video of that in the chapter current electricity. Please go through the video if you do not know the formula. But now he is saying resistance wire of unknown resistance, and in the right gap resistance of 10 is connected. Balancing length is 3:2. The ratios are in the ratios are there in the ratio of 3:2. That implies what we can say, 2x equal to 30, x equal to 15 ohms. So, the resistance that he has connected in the left gap unknown is 15 ohms. That is one point. If the length of the resistance of that wire is 1.5 meters, we know, as we know the concept, resistance R equal to rho L by A for a wire of uniform area of cross section. As rho is already constant, resistance is directly proportional to length. Then resistance 1 by resistance 2 equal to L1 by L2. He is saying resistance of that unknown wire is x that we have calculated. It has a length of 1.5 meter. So, if R1 is 15 like we have calculated, L1 is 1.5. He is saying if the resistance is 1 ohms, what is its length is he is asking. So, this is not linked with meter bridge anyway, it is a common sense, right. So, now I can say 15 L2 equal to 1.5, L2 equal to 1.5 by 15, that is 1 by 10, that is 10 power minus 1 or 0.1 meter. That is the answer for the problem. That is a simple question. Let us have a look at the next question, that is basing on potentiometer given in NEET 2016. This is also a very simple question. A potentiometer wire is 100 centimeter long and a constant potential difference is maintained across it. That means there is a primary circuit he meant to say basically. Two cells are connected in series, first in support to each other and then in opposition to each other. What he meant to say is, in secondary circuit he has connected two cells, each one supporting each other, that means potentials add up. Whereas in opposite case they were connected in opposite to each other. So, in the first case the total EMF is added up, whereas in the second case total EMF is not added up because they are connected in opposite direction. The balancing points obtained in both the cases is 50 and 10 from the same source. What is the ratio of EMFs? You know, for a potentiometer at balanced condition, it is used to compare the ratios of EMFs, that is EMF in the first case by EMF in the second case, that is kept in the secondary circuit, is balancing length L1 by balancing length L2. In the first case two cells are connected in order, so the total EMF is E1 plus E2. In the second case they were connected in opposite order, that is E1 minus E2, and balancing lengths are 50 and 10, both are in centimeters, that is 5. Let us cross multiply. 5 of E1 minus E2 equal to E1 plus E2. Let us simplify that. 5 E1 minus 5 E2 equal to E1 plus E2. Get E1 this side. 5 E1 minus E1 equal to, take E2 to that side, E2 plus 5 E2. So, 4E1 equal to 6E2. Thus E1 by E2 is 6 by 4, that is 3:2. That is the answer for the problem. So, this is also a simple problem. Both these problems are depending on basic concepts itself. So, if you observe all the questions, as this is the last question I am solving in current electricity for a while, that is of course as of the March of 2024, we can see the questions that are appearing in the chapter are quite simple. They are all just basics. There is a lot of depth actually. He can ask so many tough questions, but he is kind and asking simple questions, the examiner, right. So, be thankful, learn the basics well, right. That is it. Thank you for watching.